Hello and welcome to another video of mine where hopefully I help you solve a problem. This is an air fryer that is not powering on. After being plugged in, there are no indicating lights that power on at all. So that means it's completely dead. So let's start by unplugging it, removing any trays or anything inside to help us basically disassemble this air fryer. Now this brand's name is Caloric, but they do come of course in many different brands. Some of them are identical with different brands. They're rebranded. Nevertheless, the insides are going to be very similar, especially when it comes to the failure mode here that you're going to see. The screws you'll have to remove are all the screws that hold the top panel. And if you follow the edges, usually you will be able to see all the screws or find all the screws that are needed to remove this panel. For this brand, you can just follow this instruction and find all the screws. Then you will have to flip it over and remove the remaining screws that are found on the bottom as well. So start by loosening the screws that you see here. Open the doors and look for these screws. Loosen them, but do not remove them, and loosen only the ones on the sides. And the reason you want to loosen these is because they do hold the sides, they pinch the sides, and we want to remove them or loosen them so that it becomes easier to remove the panel that covers this whole thing. If you don't do that, you will end up bending the panels slightly and you'll have some trouble taking them off. And basically this is where they are pinched. Next, you want to remove the screws that go all the way around from the back side that do hold the panel in. So these are the outermost screws, as you can see. Those, take them out completely and lay them to the side so you don't lose them. Now lay it on its back and access the screws that are hidden under the feet by basically removing the covers first and then undoing the screws and taking the feet completely off. Each one of these feet does hold a screw in the back or inside of it. So pop these out, remove them, and again set them to the side so you don't lose them, and remove the remaining screws that hold the panel. So the way to troubleshoot is trace the power going into your device. And in this case, we see that the electrical cable goes in, has some connections right there. There is here a thermal fuse, and it goes into the circuit board. Now start with the easy stuff. Check your thermal fuses right at the entry to the circuit board. So meaning before the circuit board, what could be broken. We're not going to be troubleshooting the circuit board in this case. There are also other connections. You may have some other fuses in line. Some of these fuses are not resettable. In this case, yes, this is not a resettable fuse. If it reaches a temperature it's not supposed to, it will break. So as I pulled on it, I was able to pull the fuse out, and you can read the specs off of this fuse. You can also check continuity if you have a continuity meter or an ohm meter across this fuse and see if it's open. If it's open, obviously that's where your problem is. Okay, and this can be replaced. Hopefully you have the right tools if it is broken on your side. If that's not where your problem is, you're going to have to continue troubleshooting across. And usually what I look for is scorch marks, burn marks, anything that is visible that shows me where the problem is. In this case, this fuse here reads 165 degrees Celsius. And so when you order, you want to order the same one, or you can order something very close to it. So if you go lower, you're going to have a problem with the tripping even earlier. If you go too high, then it won't act as a safety fuse as it's supposed to. Okay, so let's take a look at this fuse and see if it is good. So as we begin troubleshooting, I'm going to first do this using a multimeter, and it has a continuity checker as well. But if you know your multimeter, you just set it to any resistance value. You test by touching the probes together, and if you get a reading of 0, then you're good. So in this case, I tested it. It's showing that there is a reading. Now I test across that fuse. If you get any reading at all, then there is some current flowing. If you get nothing at all, like I'm getting here, it's completely blown, which is what it should do if it does reach that high of a temperature. Now I can't explain how and why. I didn't have a fire in there, I didn't have any problem. One quick way you can test to make sure your device is running even after you replace the fuse is you can bypass the fuse. This fuse is only a temperature fuse. Okay, so you're not bypassing a fuse that was blown because of overcurrent. This is a thermal fuse and it's triggered by temperature. So I bypassed it using, as you can see, alligator clip short circuit, and it does turn on. So don't touch anything because it is live wire. Now just disconnect the power and remove that jumper and replace the part. Now you can use something else as a jumper if you don't have this alligator clip jumper, but pay attention, don't touch the body and the frame of your device, your appliance. In this case it's a toaster, oven, and fryer. Okay, so disconnect power first and then remove your jumper. But now we need to replace this fuse. So how am I going to replace it when both ends are crimped on? They're not screwed on. Sometimes in certain devices they're screwed on. This is actually crimped on there. So I'm going to show you a few methods that you could do that. I actually do have the parts with me here because I've used the same thermal fuse off by 5 degrees, but I've used it to repair another appliance, so I ended up ordering a bag. It's actually cheaper, and I got it from eBay. There was another time I got a different one from AliExpress. This one does have loops. It's meant to be screwed in, or at least it's ready to be screwed in, but since in this case it's not screwed in, it's crimped, we need to do exactly the same thing, and we need it to fit back into this heat shield sleeve. Okay, so all of it needs to fit in there, which means the crimp needs to be small. However, if you don't have a crimper, you don't have any way to solidly crimp it to make sure it does not fail and that it conducts current the way it should, there are a few methods I'm going to show you. So one option is wire lugs. Wire lugs are insulated and you can just screw it in along with that thermal fuse. But you will not be able to insert it into the sleeve, so it'll have to remain outside of the sleeve and parts of it inside the sleeve. You don't want any bare metal touching the frame or close to the frame because the frame is conductive and it's grounded and it will shock you because actually the appliance and this appliance is not grounded. Okay, so be aware of that and use your lugs right at the tips so that the only thing hanging outside of the sleeve is the wire lugs, if that's what you're going to use. Of course, you're going to pull this back into the sleeve before you apply the second lug. Now, I want to mention this other option, which is not an option. These are sleeves that contain solder in the center. I don't know what alloy it is. And you can basically put two wires through, heat it up with your soldering iron, heat gun, or even a lighter. And it will melt and fuse the two joints together. It will join them pretty well and also has a heat shrink. But here's the problem. Uh, these solder alloys melt starting at 90 degrees Celsius. That's lower than the fuse's rating. So you have a problem there. Don't use them. These are some other options, and sometimes I improvise. I'll grab one of these. This is what I used to do. I'll clip part of it and then use the remaining part um, as a crimp and to create a connector. So if you have those laying around, you can cut the connector part and leave the lug part, the round part. Put your wires through it if they fit and crimp them maybe with pliers, but you have to make sure you don't beat them up so they become soft and lose connection. I've also used this kind of a connector as a crimp. So put wire in each fold that you can see and then bend them so until there's a very good solid connection. But you do want to cover those with some kind of a cover. You don't want to leave them exposed, so heat shrink would be a good idea. If you don't have any of those, don't use electrical tape. This is a heating device, and so electrical tape will melt, will burn. So that's another option. I'm just giving you all kinds of options to see whatever you have laying around the house so you can fix this yourself. I did buy this crimp kit. It's very inexpensive from Amazon. I don't remember the cost, but you can find something like that. And it's meant to crimp for a different reason, right? It's meant to crimp these connectors. But I've also been able to break them off and crimp wires together. So that's another option. One quick note on this. This crimper is not meant to crimp inline, but rather like an edge crimp or an end of wire crimp. But this is inline, as you can see. So I can't put the crimper in there and crimp it. Therefore, you have to fold them together and then you install the crimper from the outside. And so it'll have like a V shape. I guess that's the closest description I can give you. So it's not going to look like this and be an inline crimp that you can pull inside. But I will also show you what other option or another option that I have. Let's go ahead and start repairing this. So first I'm going to cut the wires. I'm going to give myself some room here. So I'm cutting it at the edge of the thermal fuse. Okay, and you can see there's the crimped part that's left behind. Now with the other one, of course, it's got insulation on the wire, which we will need to remove, and I'll need to cut this loop because we're not going to use it. Now if it was a screw-on like you can see here with the heating element, that would have made things way easier. And sometimes I do look for that path. But it's too far and I'm not going to stretch this wire. So we're just going to have to cut it or modify it and use it. So here I'm cutting my thermal fuse to size, as I said, after stripping the insulation. I've already measured how much I need. Depending on the crimping method you're using, make sure you measure exactly how much you need. Prep the wires by cutting off the old crimp if you're not going to use it, and in this case I decided I'm not going to use it or the wire from the old thermal fuse that was burnt. I was going to use it. If you have a wire stripper, a fancy wire stripper like this or anything simpler, you can try using it on the wire. If the wire is too stiff, you may have to help it out, or you can use these are precision needle nose pliers. That should work. Don't cut the wire too short because you're not going to get it back. The wire lugs, line up the fuse wire with the wire from your device and just basically screw it on if that's what you're going to do. Then you slide it through the sleeve, get it from the other end, and do the same thing on the other end. Now here for me, because that's not what I wanted to do, it is short. That means I'll have to either have made it longer or I would have to cut the insulation so that at least it's still covered and I'm able to apply the lug on the other end. So now I'm going to be installing these crimp-on lugs that I showed you earlier, and I'm going to reinstall the heat shield on the wire of the thermal fuse. So I slide on this crimp, I slide on the wire of the thermal fuse, ensure that the insulation is on there, and we'll use the crimper now, slide it in and crimp the plug. And so that's kind of neat because now you have a permanent connection that will not melt when it heats up like solder would. So you don't want to solder these, definitely. And it's permanent. I can slide this inside of the shield over there, and it'll be insulated, and I don't have to worry about it. So now here's the problem. Because the type of crimp I have to slide it inside of the crimp. I can't do it for the other end of the wire. So the way I'm going to do that is a little differently. It's going to be from the outside. Now I needed to do some cleanup because there's still some insulation around the wire I stripped, and I could not get that cut and clean, so I just burned it off. And it's plastic and thread. Got that taken care of, so now I exposed the wire. With the wire exposed, now I'm just going to line up the thermal fuse after I put the insulation in and get that crimped as well, and then slide it inside. Because obviously the other way it's not going to work. That my crimp is not an open end. It only, I don't know what it's called, but it only slides on the outside. So anyway, put the insulation back on and get the crimp, line it up, and do the crimping. Now, if you have these lugs, one thing you'll notice they do have these plastic sleeves on, and they can be convenient if you, depending on your application. But in this case, I need to slide them inside of the heat shield, uh, and that's not going to work. So instead, I break off the plastic part, and I'm left with just the metal sleeve, which is what I want. Install it, and I've done this many times before in this kind of an application. And now it's exactly how I want it to be. It's crimped both wires. I just need to now bend it in the same direction so I can slide as one of the wires, and this way I can slide it inside. I'm lucky because that sleeve is large enough. If not, I would have probably used heat shrink and applied it to it. Now I'm pulling everything back in so that the thermal fuse is actually almost in the center or lines up with the metal bracket that is attached to the oven, and this way it transfers the heat to that fuse in case it overheats, and the fuse then does its job as it's what's supposed to do. Remember, it's a safety device. It's not a functional device, meaning if you bypass it, it'll still function, but you just won't have that safety uh, device that's preventing maybe a fire. And this exists, of course, in all devices that have heaters in order to prevent fires. So once you make sure it's in there and there are no exposed conductive wires or parts of this fuse, you can go ahead and do the testing before you put this together. Okay, so plug it in, and there you go. It turns on, which is what it wasn't doing before. And that's really as far as you need to test. But you can turn it on, activate it, and watch and see what happens. Don't touch anything at this point because you do have power going through all the parts. And since it turned on, the heater turned on, I mean, clearly once you see the lights, you know it's working, because this one actually, this fuse cuts off power to even the circuitry. Sometimes there are fuses that cut off power only to the heating element. These are switches usually. And if these go bad, then the heating element won't turn on. In this case, it's the entire appliance. So you're good to go. I did disconnect, of course, to make sure there's no power before touching everything. I was checking to see if there was anything warming up in case there's a poor connection or poor crimping. Otherwise, we're good to go. Congratulations, you've fixed your device. Now just put everything back together and you should be as good as new. Hopefully you've benefited from this video and you've saved yourself some time and money and learned something new. Please do like and subscribe. I'm trying to produce more and more helpful videos, and hopefully the quality of my videos will be better each time. But I need your support. Thank you.